Good afternoon, good evening, or good morning, depending on where you are in this world, and welcome to today's Security Boulevard webinar. I am Charlene O'Hanlon, Managing Editor of Security Boulevard, and I welcome you to today's webinar. Before we get started with things, I would like to go over just a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of the event, please know that you'll be receiving a link via email post-event that you can access the webinar on demand. And also, we will be taking questions from the audience. So at any time during the event you have questions, just use the control panel and we'll try and get to as many audience questions near the end of the webinar. We'll take about 15 minutes or so. Okay, with that, I'm actually going to turn things over to Ajay from Shape Security, who is going to moderate the rest of the event. Take it away, Ajay.
Thanks so much, Charlene, and thanks for everyone joining us on today's presentation. I wanted to just quickly walk through the agenda of what we're going to discuss today. We're joined by two industry experts, Justin Richer, who's the co-author of the NIST Digital Identity Guidelines. Justin is also a systems architect, software engineer, standards editor, and service designer with over 15 years of industry experience. He wrote The Vectors of Trust and is a co-author of NIST Special Publication 800-63, version 3, which he will get more into in the first item on our agenda, which is an overview of the NIST Password Guidelines and what you need to know. Our second speaker today is Gautam Agarwal. He is Senior Director of Product Management at Shape Security and has many years of experience in various leadership roles across product and engineering. Gautam will be explaining how every company can implement NIST guidelines with Shape's new offering called Blackfish. After both the presenters have gone, we will, as Charlie mentioned, open it up to Q&A. So please send us your questions on the question tab on your console. And without further ado, let me turn it over to Justin.
All right, thank you very much, Ajay. My name is Justin Richer. I am an independent consultant working out of Boston and do a lot of stuff in the space of security, and you can tell I'm a security professional because we're going to start off with the cyber hoodie slide here. This is how you know this is a serious security presentation, right? Well, okay, really today we're going to be talking about passwords. There's a lot of different aspects of security, but today we're going to be focusing on passwords because they are everywhere. We use passwords for all different kinds of systems, logging in left and right, day in and day out. But one of the most interesting things about passwords is that they are, in fact, an ancient technology. They have been around for a very, very, very long time. But I want you guys to stop and take a step back. Don't think of how we use passwords today, but think of how passwords have historically been used. A password is all about knowing the correct word to say when you get to a door or a gate, when you're trying to get into something and you need to know the word in order to allow you to pass. So you're going to say the password to the doorkeeper and they're going to open it up to say, like, yes, you know the secret word, so you can come in. The password is all about the door. And this works because it is a construct known as a shared secret. Now, a shared secret means that I know it, the doorkeeper knows it, and I can prove that I know it by telling it to the doorkeeper or proving that I know it to the doorkeeper, and then the doorkeeper will let me in. This all works pretty well, but you might be thinking to yourself, shared secret, that sounds kind of funny. If it's shared, how is it a secret, right? And that is an absolutely valid question. And in fact, the way that we think about secrets today at a lot of times, the more you share them, the less secret it is. But in the ancient application of passwords, when you're going and using it to get into the secret club or what have you, that's actually assumed that everybody who knows the secret is allowed to be in there, and you control who you tell the secret to. And if you need to change the secret, you change the secret for that door. You tell the doorman that, yes, this is the new password. Anybody who shows up with this new password can let in. Anybody with the old password, don't let in. But that's not how we use passwords today, is it? Now, today passwords are no longer used to say, you're allowed to get in the door. What passwords are more about is logging into a system. You ask for your username and your password. We see this all the time, right? So what we've instead said is that the password is not about the door that you're trying to open, that you're trying to get through. The password is about you. The password is saying who you are. In other words, we've taken something that has historically been authorization. I know this, therefore I'm allowed to go through the door, and we've turned it into authentication. I know this, therefore you know who I am. But if you think of this back into the analog space of this password to the secret club door here, then that doesn't really make a whole lot of sense because, if the doorman knew who you were, that you wouldn't really necessarily need to know the password. If they knew who you were, then you might be able to get in or out with or without the password because they know who you are. So we're applying passwords today in kind of a strange way if you look at sort of the entire history of how passwords work. That said, we are absolutely using passwords everywhere, and so it's a good idea to have good guidelines for how to use them and how to use them properly. And they are so pervasive that, in fact, the U.S. federal government has come up with a very obtusely named document, the Special Publication 800-63, that tells you, among other things, how to use passwords properly. This is something that is available for free online from the National Institute of Standards and Technology. And it has a whole lot of really great stuff in it, but this is where it's most famous is a lot of people hear about levels of assurance. Now, very shortly, this isn't the topic of today's conversation, but levels of assurance is how strongly can I be assured that you are the person that you claim to be. You know, this isn't just like how well did you authenticate, but it's also like how did I know that you are the person that, you know, has these names and these attributes and stuff like that. That's all rolled up into levels of assurance. But another thing that 800-63 has is guidelines for how to have good passwords. So we have passwords everywhere, so we're going to start really thinking about how do we have good ones, right? We want to be able to apply this appropriately. And there's a lot of guidance in that has been in 800-63 for a very long time now. And these are going to sound familiar to a lot of you guys. First of them is we enforce rotation of the password. So every 6 months to make sure that nobody steals a password and then can use it forever. Right? We got to make people change their passwords. We see this a lot, right? We also don't want people to have simple passwords, stuff that's easy to guess. So we're going to have some complexity requirements around it. So when I pick a password, okay, let's go with this. You know, this is my password. It's something simple. I can remember. All right, we can all say pretty easily this is a pretty bad password, right? It's short. It's a common word. It's the word. It's not a good password. Okay. We want people to pick better passwords, so let's start putting some guidelines that we can enforce with programmatic systems. So we're going to first say, like, all right, you can't have a short word. So at least 6 characters. That'll get us out of, like, super common. You can't use the letter A as your password. Sorry. So, oh, great, fine. I'm going to double the length of my chosen password, and it is now password. Okay, so that's also not very good, even though I'm now complying with the length rules of having at least 6 characters. I've still picked a bad password. So how are we going to make people pick stuff that's a little bit more complicated, a little bit harder to guess? Great. We'll tell people to use upper and lowercase characters. Now, this belies the origins of the document 800-63 as kind of a U.S.-centric thing. But that kind of makes sense, and I'll give NIST a pass on this because it was originally written for U.S. federal government employees working on federal government systems. A lot of English-based stuff, but there's no upper and lowercase kanji, for example, and lots of other scripts around the world. So, all right, fine. Latin text, upper and lowercase. Great. Now I picked a new password, and it's secure, right? Okay, we're all looking at this and saying, like, no, that's not a good password, right? It's still just as bad as before. Okay, fine. We're going to make you, in addition to the upper and lower case, you're going to add numbers and symbols and special characters and all this other stuff like that. And then, okay, fine. I will jump through all of your hoops and come up with a great password. I'm going to take that password and do some common substitutions, stuff that is, visually and graphically similar so that I can remember that. So it's a 0 instead of an O because hackers never think of that. And this is going to be my password. Or maybe I'm going to feel really clever and I'm going to put that capital in the middle instead of at the beginning because, an attacker's never going to think of that one. Or I'm going to put a number at the end. You want me to add a number? I'm not going to try to remember if it's an O or a 0 or whatever. I'm just going to throw a number at the end and we're going to call it a day and then, we'll be fine, right? So these passwords, they pass all the rules, don't they? Right? These would work on most systems. And in fact, if we look at the entropy calculation across all of these, we can see that every time we've added one of these rules, we have increased the entropy that is in that password, which means as a result, it is harder to guess. And but we've also consequently made it kind of harder to remember. Because by the time I get to these 3 down at the end, I have to remember, like, okay, did I put the number at the end, or was it in the middle, or was it both? Did I put the capital at the front or the back, or, what was it? So I now have to, as a user, remember all of these different transformations across the word that I had chosen in the beginning, and this is supposed to represent me, so this is probably going to be something that I'm going to apply a lot of different places and be meaningful to me. But the truth is, like, these rules are everywhere, and it's considered kind of common knowledge to do everything this way, right? Just about every site that you're going to go to, every application that says pick a password, it's probably going to say you have to have upper and lower and it has to be at least 8 characters, all of this other stuff like that. It's common knowledge that this is what makes a secure password. But the truth is, these are all horrible passwords. Everything that I told you so far, everything on that chart, no matter the entropy, is a terrible password. Why is that? Well, because it's all been made available in a publicly available webinar. If these were not in lists of passwords that people were checking, as part of an attack, they will be by the end of the call. And so, get on that, guys. And they're going to be in these lists. So we meant, NIST really had a good goal of making everything go, making people have better passwords and more secure systems. But let's take a step back and look at the reality of the situation. How do things really end up in the world, right? So we see these constraints absolutely everywhere today. So this advice was taken to heart by lots and lots and lots of people all across the internet. So it was truly pervasively applied. But the problem is everybody applied the rules a little bit differently. So the whole idea of federal government level style guidelines is that everybody reads this and everybody does it the same way so that everything's like predictable and secure and good and all that stuff. But we started to see some really weird interpretations of this. People adding their own rules. For example, having an upper limit on the length. Now, the guidelines don't say to put an upper limit on the length. They say to have a lower limit. You have to have at least 4 or 6 characters, depending on the character composition, all this other stuff like that. But we see time and time again, lots of different sites that say you need to use a certain number of characters, right, at most. And the reason for this is that often a lot of developers will basically go through and they're building a system saying like, oh, hey, I'm fairly smart. My password is 9 characters long. Somebody else is probably not as smart as me, but I'm going to let them have 12 characters because there's no way somebody's going to remember a password that's longer than 12 characters. Well, yeah, especially if they're jumping through all the hoops of upper and lower and all of this other stuff like that, So it's probably not going to be any longer than that, so I'm just going to do an upper cap. That makes it easier for me to do string processing and storage and everything else. We see this all over the place. That means that a password that I chose at one place, and remember this represents me, might not work somewhere else. I might not be able to use something like that. We also see a lot of places that limit the characters that you input. Now, what's funny is that we have a lot of sites that require special characters, but we've also got a lot of sites that require that you don't use specific special characters. And this is a lot more pervasive than I thought. Like this one is particularly terrifying because this is a screenshot from an actual bank. You must be between 6 and 8 characters. You can't have spaces or special characters in it at all. You can't have consecutive numbers. And so what this is giving me, if I were to attack this particular bank, I can write a Python script in a matter of a couple of minutes to generate the entire password space that is allowable at this bank. And it's probably not that big of a text file, right? Everything between 6 and 8 characters, I can throw out huge swaths of my search space and narrow it down. And the thing is, they did this in the name of being secure, right? Which is really, really kind of strange. We see this kind of stuff and different variations of it all over the place. These guys at least say, yeah, don't use password as your password. Okay, that's good. We got to give them points for that. But, can't contain 2 separated numbers. Like, who came up with that one? I do not understand that one at all, personally. I just have no idea where that came from. And this one is I find particularly interesting because you cannot contain the characters hash, ampersand, plus, or space. Now, any web developers or anybody that's done web APIs on the call here is going to recognize that as somebody didn't do their form input validation and URL encoding properly. Which, in other words, to folks like me, that means, hey, come and try and do injection attacks against me because I'm not paying very much attention to this validator. So, yeah, you really need to, a lot of people have done really weird limitation stuff like that. We've also made it so that these passwords are really hard to type, especially in a mobile device. Now, the original guidelines where these passwords came out and really kind of popularized it, they were written for federal employee systems where at the time it was somebody sitting at a desk with a computer that was plugged into the wall, a desktop computer. Everybody remember those? And that's not how people interact with systems anymore. We've got touch screens. We've got, soft keyboards. So, typing, right quotes and ampersands and all this other stuff, it takes multiple keyboard flips to kind of get to all of these special characters. So we've made it really, really hard for people to use these kinds of things. And the thing is, we thought as a community that we were doing a good job at fighting a couple of key attacks. We thought that we were fighting people picking bad passwords, picking just really dumb, easy to guess passwords. And that's true. People will pick really dumb passwords if we don't have something to force them to pick non-dumb passwords, right? That is absolutely true, but that's far from the only thing here. And the rules that we've created make them pick passwords that are still bad, but in more obtuse ways that are less easy for us to detect. We also thought as a community that we were really protecting against sort of brute force attacks. You get an attacker that they have one account and they're just going to hammer every single password combination against that account until they get in. But the truth of the matter is that's not really what we're fighting out in the world. That's not really what we're seeing, especially in today's world of interconnected multiple devices and people using different systems across the web that are disconnected from each other, that you've got the same person. Well, we said the password's about me, right? So since the password's about me and it's not about the door, I'm going to use the same password everywhere since it's identifying who I am. So I need it to be about who I am. And that means I'm going to use the same password in, 100 different sites that never talk to each other. Problem is, if one of those sites gets hacked, that means my account is now available to be breached on all of those different sites. Because somebody was able to get my password over here, they can start using it over there. And these sets of passwords even become available on the black market. People will, bundle these up and, just sell them to the highest bidder and just put them out there, or even just get dumped for free into paste bin sites and things like that. Your passwords are probably out there somewhere, and the most common ones absolutely are. And there's also the problem of offline attacks. We have this whole idea that it's always going to be against a live system, somebody just typing in passwords until they get in. But no, people are going to be downloading hash databases and doing hash comparisons and all this other stuff, creating rainbow tables to see whether or not what they have is a good credential and what else it might be able to be used for. This is a very different kind of attack than what has been protected by with all of the requirements that we've had here till now. And finally, one of the biggest things that people do is they don't even think about the password. They just bypass it entirely. And, we saw this a lot about 10 years ago with the release of the Firesheet plugin, where at that time, a lot of sites would, you would go through HTTPS for the login, and then it would drop you to an unencrypted session with a session cookie for the rest of it. Yes, a thief couldn't steal your password, but they could really easily steal your cookie. And they don't need to steal your password if they can steal your cookies. Right? So people are just bypassing all of this stuff entirely because security, as it turns out, surprise, surprise, is not a single event kind of thing. There's a lot of different aspects and portions to this. So we have succeeded in creating a pervasive mentality of passwords that are hard for people to remember, but relatively easy to be cracked by attackers. We've made it difficult for the good guys and fairly easy for the bad guys. And that's kind of the opposite of what we would really want a truly secure system to be, right? So we really, as a community, need to do better than this. We absolutely have to do better. And I was privileged to be able to work with NIST on an update of the special publication 800-63 over the last few years. And we published revision 3. It's available for free on the web right now, the Digital Identity Guidelines. And this changed a whole lot of things. That levels of assurance, there's a whole new, multi-dimensional model to that. Lots of really good stuff in here. I'm actually really proud of what we, as a team, have been able to put together in this document. But one of the more interesting things for our topic today is that there are new guidelines about how to have good passwords. One of the most important guidelines is don't rely on passwords for everything. Use multi-factor authentication. And yes, multi-factor does not mean 2 passwords, right? It needs to be different modalities, different things that you can present. And don't rely on a password to be like the be-all, end-all credential of if you get the password right, then everything else must be okay. Like, be more adaptive, be more reactive. And, excuse me. So we also dropped all of those complexity requirements because the research and the math has showed us that it turns out that having all of those like extra characters and stuff, yes, it does increase the entropy a little bit, but not nearly as much as you might think. What does help for people remembering things is to allow all different kinds of characters. Because if I can type a space in my password in one site but not in another, then that means I'm going to pick the sort of the smallest common denominator. Because again, I'm a user, I'm probably going to use the same one everywhere, even though I'm quote unquote not supposed to, right? So allow people to input anything they want, anything that they can type, all of Unicode and then some, into this as inputs. And also don't put an upper limit on the size, which means that we can now allow passwords like this. Now, this was made famous by the webcomic XKCD. This is a password. This is not something that you use to create a password. This is the actual password. So you have a random number generator pick 4 random, simple words that you then memorize in order and just put them down with spaces between them. Now, this is not going to pass muster with just about everybody's password validator because it doesn't have uppercase and lowercase. So obviously, this must be a really, really insecure password, right? Everybody looking at this says, yeah, this is probably not a good password. Well, as it turns out, it is worlds better than even the complex ones that we had before. Why is that? Because it's the length that is the most important part of this in terms of input to hashing, in terms of guessing across entropy and stuff like that. The length of the input string is much, much more important. And if you look at the numbers up there, you'll see that the biggest jump that we have between all of those categories is when we go from word to password, right? And the next biggest jump is we go from any of those all the way up to correct horse battery staple. Now, adding like the special characters and numbers and stuff, look at the difference between password and password with the dollar signs and the zero is absolutely negligible. There's really, really not a difference between those. And even though there's like almost no difference, we've made it much harder for a user to remember with practically zero benefit. And that brings me to the next point of, remember, people don't necessarily need to pick their passwords, but they do need to memorize them. I think that we need to really consider what passwords were originally designed as. It's the password to the door, right? This is the password that you use that if you have this, you're allowed to go through this door. This is not necessarily something that says, this is me, who I am. Because people, it turns out, are really, really bad at picking random things. We are demonstrably bad at this. Computers are pretty decent at picking random things. People are good at memorizing things. We're pretty good at memorizing random things, especially if they're, follow certain constraints and stuff like that. So if you get a system to generate a set of 4 random words, you can string those together. You can even make a picture of correct horse battery staple, and that kind of makes sense. You can actually remember that and use that going forward without really needing to memorize, like, okay, did I do this transformation of this, string substitution, things like that. Now, we do want passwords to still have minimum lengths because, again, the length of the input string really, really does matter. So even though we want to allow people to have spaces and Unicode and emojis and stuff like that, this is a really awful password. It is still correct horse battery staple, but it's only 4 characters long, 7 if you count the spaces. And I was really sad to find out that there's no staple emoji. So it's actually correct horse battery paperclip. Regardless, it's still a bad password. Not only because it's really short, but it's now also been in a security presentation. And correct horse battery staple itself has been in a lot of presentations. It's really famous. Both of those, even though we had an entropy of 104 bits there, it's a terrible password because that's going to be one of the first things people are going to try. It's going to be on the list of things that I'm going to try against any account that I'm trying to crack into because it's going to end up being really common. So the whole idea here is like, you don't pick something, you memorize it. Now, on to password rotation. This is something that I think that a lot of people have misapplied password rotation. We used to think that, rotate your password every 6 months. So that way, if an attacker gets it, then they have only 6 months to exploit your system. That is an absolute eternity in internet time. An attacker needs 6 milliseconds to exploit your system and call all of your APIs and go on with their day and go find the next account. right? They're not going to be sitting on good passwords for 6 months, poking in and stuff like that. They're going to have moved on to the next target. So where you want to rotate is where you think something might be fishy, where you think that an account might have been compromised, where you see something that like, oh, it looks like somebody else has your password, maybe you want to change it now. Because forcing people to rotate proactively ends up forcing people to pick really bad passwords. Now, password one was a password that I had on a large corporate system for years that had, it passed all of the requirements. It had special characters, it had numbers, upper and lower case, but it was a terrible password, and I knew it at the time, and I chose it specifically as a, sort of an internal, petulant protest of my own of terrible password policies. And I had to rotate it every 6 months, which means that I then had password 2 and password 3 and password 4 and so on and so forth. And these are all really, really awful passwords, and they were made worse by this policy of forcing me to rotate all the time. If instead I had been able to pick a very long, very secure, but still simple password, then I probably would have kept that for a long time and my account would have been much more secure. There's a lot of stuff in the new guidelines about how to properly hash and salt your storage so you don't end up the victim of a rainbow tables offline attack or something like that. Not going to get into the details here, but this is vitally important if you're doing any kind of password-based system. And one of the newest requirements is that you check everything against a blacklist. Now, I've mentioned several times here that all of the passwords that I've talked about today, they're bad passwords. Don't use them on your accounts. Not because of any entropy or complexity requirements, but because they're in a presentation that's being broadcast over the web and recorded. And these slides, I think, are going to get posted too, right? Yeah, I think, yeah, I'm getting nods. And so that means that, attackers are going to say, hey, these are passwords. Somebody's going to look at this and say, a security professional said this was a good password with high entropy. It's true it has high entropy, but it's a terrible password because it's been listed and it's going to be in a list of common passwords. People are awful at picking random things. People pick the same random things a lot. And so in the background of the slide here, this is a real table of the most common passwords across multiple systems across different years. So you see password is up there along with 1, 2, 3, 4, 5, 6. And interestingly, if anybody wants to guess the year that Adobe Creative Cloud came out and people had to start getting Adobe accounts, right around 2013 maybe, where Adobe 123 became one of the top passwords, right? Because suddenly people had to create a new account. They didn't want to have to think about it. Okay, Adobe 123, yay, it's got letters and numbers, it's secure, it's at least 4 characters or whatever, right? No, it's an awful password because everybody else had that same clever thought, right? You also don't want to allow people to use passwords that you know are broken. Like say there's been a big breach and there's, sets of passwords that are floating around that somebody's used the same username and password on a remote site that got broken. You know that they're using the same username and password on your site. You don't want to allow them to do that. You want to say like, hey, we have an idea that maybe, this password's no good anymore. You want to rotate that now. So you want to rotate it reactively and don't let them pick something that is already broken or they're going to be targeted. So there's, of course, this question of when do you check this? Because right now I think about when do we check password complexity requirements? It's when you create the password. And then you just throw it in your database and forget about it, right? We don't live in a world that's that static, though. And this is part of where the whole password rotation thing intuitively made sense to people. It's like, oh, we can recheck these passwords every 6 months for complexity. Well, the problem there, of course, is that people start picking things that are much less secure so that they can deal with this constant rotation. So the better question is not necessarily when do you check it, but you do want to check it fairly often, but how do you check it? Are you keeping all of your passwords around in plain text and then comparing them against the blacklist? Probably a really bad idea because then you've got a very, very valuable list of passwords that everybody might be able to go and, or at least target you for attack to download that and then go use somewhere else. You don't want to be able to do stuff like that, right? And you don't want to train users to say like, oh, hey, here's a form, tell me your password, and I promise I'm gonna tell you if your password has been hacked or not. Because for somebody like me looking at this, that says like, hi, tell me your password so that I can use your password to hack you on all sorts of other sites. Like that's what's really kind of going on here, at least that's what should be triggering people. But if we train people to say like, oh, tell us your password so that we can check it, or even, automatically, send your password to your password kind of as it is to this API, so this API can check it. Terrible idea, because we're telling people to give up their secrets that are supposed to represent them directly. So there's this whole question of where do you even get this list that you need to check against, right? And this brings us to the question of whether you're going to build this yourself or whether you're going to outsource it to somebody. And there's always a trade-off here. There is no one simple answer to this. There is no one argument that is good for everybody at all times, and there never will be. Anybody that tries to tell you that there is only one way to do this is selling you something, and they're selling you whichever one they said is better, quite frankly, because there are trade-offs. But this is an interesting trade-off space in this case, I think, because if you're going to be building it yourself, you have the power of complete customization. There's a lot to be said for this. Because, say your users are in a particular domain and they're more likely to pick bad passwords that are related to, say, a particular sports team or sports teams in general, or a particular industry like medicine or shipping or something like that. You can account for that when you're looking at your blacklist. You can account for these sort of, local anomalies, these sort of local maxima that you might be susceptible to that other people won't be. And if an attacker is targeting you and your industry specifically, they're going to know this kind of stuff too. So this is a valuable thing. But you also need to be able to manage this list, which means that you need to go get it, keep it updated, and make sure that it has all of these customizations, and these customizations actually make sense. Which brings you to the question of where do you even go get a password blacklist like this? I mean, there are a bunch that are out there on the web. I mean, I'm sure there are subreddits for these kinds of things all the time. Random paste bin files of passwords and hashes and things like that. There's also all kinds of stuff out on the dark web and illicit markets that you would be able to get this kind of stuff, right? You could alternatively use a service to tell you if this password's, a particular password that you're looking at is good or not. And there's a lot of value to this too, because that means that, you don't have to manage all of this, but of course it raises a very, very big question and warrants the return of the cyber hoodie in the background. This is a very deep security question here. How do you trust that service? How do you know that they're going to, that they're going to give you the right answer, whether or not that password is good or not? But also, how do you know that they're not going to take whatever you send them and go use it, right? Because if I were to set up an API that says, give me your password, just, put it in a web form, post it to me, and I will go look it up on my list and tell you if it's there or not, yes or no, and then we're good. A service like that is, I guarantee, at some point going to take all of those passwords and just start writing them down in the background. Because you're creating a very good corpus of like, hey, here's a whole bunch of passwords that haven't been shown up in other people's lists yet. That becomes very valuable. So if you're dealing with any service, you really don't want to have something that allows that to happen. But there are ways to ask these types of services that don't divulge that information. Now, finally, if you are using a service that's set up well, then you've gained some collective benefit in a couple of different ways. First, if you are a large-scale provider, you'll get the benefit of being able to be very reactive because you've got a lot of different users, and if one account is compromised and you're under attack, then hackers are not going after singular accounts. They're kind of broadcasting and saying, like, we've got a bunch of credentials. Which ones work, right? You're going to want to know how that's happening across all of your systems, which might be very, very distributed. So having a service that you can call to collect that stuff makes a lot of sense. On the other hand, if you're kind of a small provider, then you're going to benefit from all of the input from these large services, because they're going to be the ones that are going to be the first targets of large-scale credential stuffing attacks, and that you wouldn't necessarily see the benefit of right away if you were building everything yourself. Because they're going to bear the brunt of the first wave before the attackers come target you. And finally, those smaller scale systems are more likely to be the ones that break. I mean, quite frankly, the little mom and pop website that, somebody's cousin set up a password server or something like that, that's more likely to get cracked and more likely to be the source of bad passwords, less likely to be the initial target, but definitely more likely to be the source. Now, in today's world, everybody bears the burden of that because users are reusing their passwords everywhere. But when that small site realizes that they've been hacked and they tell all their people, change your password here, nobody else is benefiting from that knowledge, because it's cordoned off in some tiny little site on a corner of the internet somewhere that nobody's ever heard of. So there's a lot of trade-offs between these two spaces. I'm not going to tell you which makes the most sense for you, because I really don't think there is a single answer. I honestly do believe that there is not a single answer. But I am now going to hand it over to Gautam, who's going to tell you about how Shape Security is hoping to address this with their new product.
Thanks, Justin. That was very informative. I'm sure our viewers will appreciate the perspective that you brought in and the reasoning behind some of the changes to the NIST guidelines. Specifically, I want to pick upon the password blacklist that you mentioned. Where do you really begin? How do you make that blacklist? And we've been at Shape, we've been dealing with this problem for even before when these newer guidelines were published. We think of it from two fundamental angles. That is, when do you start to begin building a list like that? And for that, we must understand how the breaches happen and how it plays out, how that information gets delegated or show up on dark web or underground markets. So I'm going to use an example of the Yahoo breach. Yahoo was breached in 2013, the infamous breach. They did not even find out until 2016. And in 2016, or sometime even before that, some of that data started to show up on the dark web. But if you think about the attackers who actually breached Yahoo, they must have started to use that data to credential stuff several sites because of password reuse and extract the maximum value out of that data. Then they did not do it for just selling it on the dark web. If you are, you're not going to put your newest clothes in your garage sale. You want to wear them first, use it, and then put it in the garage sale. So there's a big lag between when an organization is breached, when that data is with adversaries, and when it starts to really show up for anyone to create this blacklist, which is what is recommended by NIST. So from that perspective, the list generation, any kind of list that we're talking about here, must start right at the point around the breach when those credentials were being used in any attack at the first time. That would be the ideal situation, because then you have avoided the window which basically exposes your users to the risk of their accounts being hacked. The second element of this list is basically what should be in the list. We've been researching on this as well, and some of the cybersecurity research says that we today have about 90 billion passwords that are being used across mobile and web applications by different users across the globe on the internet. Now, that's a large number, and that is expected to grow to 300 billion, which is more than 3/4 increase in the next 2 years. And if I just look at that number and assume that some portion of that will be breached or is already breached, the list of stolen password, or if I should call it, the universe of stolen password, is very big. It has stuff that is detected in breaches, when breaches are detected, and there are a whole bunch of them that goes undetected. So the overall list should have everything that were stolen, not the ones that were detected. And following the timeline of some of the things that I presented in my last slide, the portion, only a subset of this will show up on the dark web when you basically go to put a garage sale of those stolen passwords. So from a list generation perspective, your ideal blacklist should have every single password that was ever stolen, and that's really hard to get to. But the typical blacklists that are available from the sources that are easy to mine are from the dark web. And we've seen a number of Password-Blacklist-as-a-Service vendors that are doing a good job of providing that service, but it's almost too little and too late, because you want to focus on the window where the breach happened versus before, the passwords, the stolen passwords started to show up. And you want to also make sure that everything that is out there is somehow being compared against to make sure your passwords are secure. So the real answer from our perspective to that question is we should go to where the stolen credentials are used for the first time ever. And that's what Blackfish does. at Shape, we have built a solution to this problem where we start generating that list right at the moment when we see the credential stuffing attacks from right after data breaches that happen. Any new data breach, we start to see credential stuffing attack across a number of our customers, and I'll talk about that. But that's the time we can start building that list. Now, how does it work? How Blackfish works is basically, as soon as we observe credential stuffing attacks, we start to capture credentials used in those attacks into a knowledge base of this stolen password that Justin talked about. And there's an API service that basically literally lets you to, in real time, check against the ongoing buildup of that list to make sure that your users that are using the passwords in real time are not using something that is spilled or something that's stolen somewhere. So at any given moment of time, you're basically checking it against a list that is constantly growing. It is getting feeded by the attacks that are happening in real time. So the question becomes, so fundamentally it sounds right about, this is how we should solve the problem, but why Blackfish and why Shape? Another aspect of this problem is, when the attacker gets this list, when the attacker hacks into a Yahoo or a Equifax and they get this data, where are they going to likely use it first? And Justin talked about it as well. They're going to likely to use it against the largest targets in the world, the largest banks, the largest airlines, the largest hotel chains, where they can extract the maximum value for themselves. And Shape has actually built up a network that protects some of these largest enterprises across these verticals, 3 of the top 5 hotels, 3 of the top 4 banks, 5 of the top 10 retailers. This network is where we see most of these attacks happening. This is the network that allows us to use the information that we are collecting during credential stuffing attacks in the form of a network and create those collective benefits that Justin was talking about. If Bank A was breached, the moment it was breached, we have that information that the attacker was using. It gets put into our knowledge base, and other banks and other airlines, anybody in our network is now able to use that information to invalidate the use of that password that's basically no longer a good secure password. And we do this very efficiently and very efficaciously. All the solutions, the Shape solutions that we have deployed over the last 5 years or so in these industry verticals at these largest customers, we're very efficient in identifying and mitigating credential stuffing attacks to the tune of 99%. Most of the times we would know there's an attack happening and we would immediately block it, mitigate it, and at that time we were able to capture these stolen data. Just to give a sense of volumes of how much data that we are looking at or how much data is flowing to our systems or this network, we are observing about 500 million transactions a day, which, and specifically about the login traffic, 100 million login traffic. That's where basically the account takeover or credential stuffing attacks starts to happen. 100 million logins per day is representative of about 50% airline industry traffic flowing through us, 60-70% banking traffic flowing through Shape. So that network is one of the widest networks you can imagine to be able to capture the use of stolen credentials in an attack. Now, that's what the premise of Blackfish is. The best network and the best detection capability will lead us to the most comprehensive blacklist that we should have in the first place if we were to follow and implement the NIST guidelines in its core sense. We can always go and use a typical blacklist from one of the services out there or ourselves, scouring the dark web. But that's, as I said before, it's going to be too little and too late. So how we've orchestrated this product, the first thing that comes to mind is, all right, Shape has a network, Shape has a detection capability. How do you make sure that it's secure? We're talking about security here. The first thing, when we were building this product, security was the first thing we have in our mind. If you start collecting credentials to be able to mitigate the risk of stolen credentials, there's chances that, when you create that knowledge base, you get hacked and that information is used against others. So what we've done is we've used a patent pending technology that uses Bloom filter, which is a space efficient database, if I should say. It's essentially a blob of bit vector that basically transforms the data into binary. It's no longer a hash table or anything that you can basically brute force. It's almost a mathematical representation of what is inputted in the system with only one capability of asking a question. Have you seen these bits before, or have you not seen these bits before? And bits being synonymous to credentials or passwords over here. So we're not really storing anything. There's no need for even shape to store credentials that we are building in the credential stuffing attack. In order for us to be able to actually efficaciously create this blacklist, as well as provide a service where our customers and anybody in the network can basically use our APIs to check against that. From a core capability perspective, what Blackfish offers is essentially the access to the most comprehensive blacklist that is there, as well as is being generated on an ongoing basis. Attacks are not going to stop. Breaches are going to continue to happen. We heard recently about Equifax. Tomorrow there will be another organization that is breached. All of that data has to be brought into this list, and that can only happen if we start to observe these attacks in the first place for the first time and be sort of pervasive across the network to make sure as soon as stolen information is used somewhere, it is available to remediate across the network. There are APIs that we've made available where any organization can basically integrate their web and mobile application to utilize the service by a simple call. Just check during your authentication whether it is breached or not. We actually go one step further than the recommendation of using at the time of account creation as well as password reset. That is from the NIST guidelines, the latest guidelines. We even allow you to check it during the time of login. So you can inform your users that, whether they are using a compromised credential at that moment. It is essentially only a matter of time when those users may be under attack. And you want to make sure that you have the capability to inform them ahead of time and not be in a proactive fashion and not be reactive to it. And lastly, we also allow monitoring services. So if an enterprise is interested in knowing how many of their users are under attack or using compromised credentials, if I should say, we can provide that information to the enterprise, as well as there are situations where we have seen enterprises are interested in monitoring some specific high-profile accounts where the breach on those accounts are more severe than a normal user account because it can do far more damage. So we have those capabilities built into the system. Now, when you use Blackfish, what is the outcome you're expecting? Basically, in short term, we're trying to provide you a service where you can proactively defend yourself and your user against these attacks, as opposed to waiting for the attacks to happen. If I'm able to check my credentials, whether they were stolen or whether they were breached somewhere at some point, that's much better than I finding out at the time of attack or after the attack. And then the second important short-term benefit or outcomes for our customers and others would be that you don't really need to handle all that complexity of managing this list, building this list, and really dealing with sensitive and really bad data from dark web. Nobody wants to go to dark web, and nobody wants to fuel that ecosystem by paying people over there and getting these lists. In the long term, Shape would want the stolen credentials to become less and less valuable for attackers, so that we can essentially end the problem of credential stuffing, and thereby reducing the frauds. So our recommendation is really don't rely on the dark web, because any list that you are able to generate from a typical Blackfish service out there is going to be too little too late. And Blackfish essentially is an artificial intelligence system that automatically creates this list and gives you what you need, how many, a simple integration to check when you need to check, as opposed to worrying about the building the entire list. That's what we have built and deployed across the network of our customers. So at this point, I would turn it over to Ajay to see if our viewers have some questions.
Great. Thanks so much, Gautam and Justin. That was fantastic information and perspective. So anybody on the webinar now, if you have a question, please go to your question tab in your console, and it'd be easier if we could take your questions written down. That way we can easily understand them. Please go ahead and submit some questions. We do have a couple of questions, so let me start off with the first one. Gautam, I think you mentioned, and Justin also mentioned this a little bit, the window of time between when a breach happens and when credentials might be detected, when the breach is detected or credentials are available in a public forum, is really the critical window. Is that, would you say that is analogous to sort of a zero-day vulnerability type scenario, or can you expand a little bit more on what makes that window so critical?
Absolutely. So, I use an analogy of, you're going to use the new clothes that you bought before you put it in a garage sale. And that's what happens when a breach happens. The attackers that breached, they're going to use that for a number of attacks without anybody knowing that there is a breach. Most companies would not even know that there's a breach that happened until a certain point in time. And it is during the awareness when everybody becomes alert and active to try to mitigate the problem. So the time between when the breach happens and the credentials being used first in an attack to the time when the world is aware of it is absolutely the most critical window to mitigate the risk of any exposure to your users.
Right, and one thing you need to keep in mind that I think a lot of people are confused by the term zero-day vulnerability. It doesn't mean that suddenly on that day you're suddenly vulnerable. It's just that's the day that everybody found out about it. You've probably been vulnerable for years, in some cases decades. 0 days have been discovered in very old systems, but they're still called 0 days because they are immediately usable. And the truth is that there are lots of 0 days out there with software stacks that most people don't know about, like the software vendors themselves don't know about yet. And that's why ongoing security research is really important. And those are the most valuable ones for attackers, the unknown 0 days, because those vulnerabilities don't suddenly crop up. It's just the knowledge of them. So I do think that is a very good analogy between the two.
Great. Gautam, we had a specific question around Blackfish's knowledge base. The question was clarifying whether the knowledge base is credentials, username and password, or just password, or kind of, giving a little more double click into that.
So it's essentially a mathematical representation of the combination of your username, password, with a unique salt applied to it, all the best practices that Justin has already talked about, and then transformed into a bit vector. And that is basically telling you whether these bits are similar to the ones that you're checking against.
Okay, great. So another question, I think most of you mentioned collective defense or collective benefits of sharing information. And Gautam, you had a very specific example of the network of customers. How do I think about, how does Blackfish and the NIST guidelines relate to fraud? Is there a relationship between losses due to fraud and what you've discussed?
Absolutely. So there are a lot of solutions out there that are focused on trying to mitigate the risk of an attack. But the credentials that pass through that, they also result in these automation reduction solutions are out there, but at the same time, there's a lot of manual fraud is happening. It's not like the password stolen information that is out there in the dark web or anywhere else is not being used in a manual fashion. People are, in fact, hiring what is called mechanical Turks, a bunch of people that are basically copying and pasting this information because they're more valid than trying something random. And that is another area that we must try to mitigate by making sure the credentials are no longer valid as soon as a breach happens, as soon as you know that the credential was so.
And Justin, in your experience working on the NIST guidelines and working with companies in the space, is there a normal starting point when people think about implementing these guidelines, which, as you mentioned, are pretty different from how people have been thinking about passwords in the past?
Yeah, so I mean, the first thing that people kind of realize is relaxing some of the additional restrictions that have been put on systems and kind of baked into systems that aren't actually helping. One of the biggest ones that I've seen is this relaxation of, rotate the password every 6 months. Because, it feels like that should change it. And even, like looking at Gautam's timelines that we had up there, it's like, oh, well, there's that big space. If we had just rotated passwords in the middle there, then we'd be safe, right? Well, not really. You might have been safe by the time it hits the public market, but you're absolutely not going to be safe in that sort of immediate window when something is breached and it starts getting used all over the place. So are you really willing to kind of play that race condition, especially when the downside is that people end up picking password 1, password 2, password 3, stuff that is going to just be very, very easy to guess and add to these lists, these generated lists of passwords that, you want to try out. So that's really kind of the first starting place that a lot of people do. Checking against Blacklist is really kind of new territory for a lot of people. A lot of sites, a lot of applications don't do anything like this now. Like occasionally somebody will write a regex on the input validator form that says, hey, you used the word password in this, and we know that that's probably bad. But doing a comprehensive check on this really is kind of new territory. And as with any new security territory, it's easy to feel like you got it right. And it's very easy to actually get it wrong, even though you feel like you've done it correct. This is not the place where most people start, which is why I think that this is a really important conversation to have. Because a lot of people, we found talking with people about the new version of the guidelines, a lot of people hadn't thought of this as something that they should even bother trying. Because we have secure passwords, so therefore they must not be on a bad list, which is just not true.
Fantastic. So I think we are out of time now. I wanted to thank both of our presenters and everyone for listening in. If we didn't get to your questions, we will do a follow-up for any questions that weren't answered. If you have additional questions as you maybe replay the webinar on demand or think of things, you can send us questions at the email insights@shapesecurity.com, and we'll help you provide insights from your questions. So feel free to send us those questions directly, and we'll follow up. Again, thank you very much, and have a great day.